Good day, students. Today we are considering a topic titled Energy Stored in a Capacitor. And let's know what it's all about. Capacitor is charged so that it can store electrical energy. While it's being charged, the charge builds up from an initial value of 0 to a final value of Q. And also, its potential difference builds up from an initial value of 0 to a final value of V. Let's see what's on the board. Energy stored in a capacitor. A capacitor is charged so that it can store electrical energy. While the capacitor is being charged, its charge builds up from an initial value of 0 to a final value Q, and the potential difference between its plate builds up from 0 to a final value V. During the charging of the capacitor, the average value of the potential difference is given by, it builds from 0 to V, which is the final. How many value? 1, 2, divided by 2. That's how we got 0 plus V over 2. 0 plus V, that's half V. The work done in charging a capacitor through an average potential difference of RV is W equals to half V times Q. How do you get that? We know that W equals to QV, but since we are dealing with average value of V, it will now be Q times half V. That's where we got half V times Q, which is equals to half QV. Half QV. But C, don't forget that Q is also CV. Is that okay? That's why we make C the subject of the formula. We have, let's make it, since we are using Q, small letter Q here, C equals to Q over V. Q over V from Q equals to CV, or when you make V subject of the formula, V equals to Q over C. Now, W equals to half. We will not use, since we are using average value of the voltage of the potential difference, we are using half QV. Now, work done equals half Q. Instead of putting V, you replace it with Q over C. Since you know the general formula, Q equals to CV. From there, when you replace it, Q times Q, that's Q squared over C, half Q squared over C. Any of the formula can be used depending on what you are given in the question. Also, Q equals to CV, hence W equals to half QV, which we are using average value of V times the Q. Okay, you now replace your Q with CV, you have half CV times V, which is half CV squared. It's a very important formula for work done. It's another one. Is that okay? It's another one. Likewise. Now, this work done in charging a capacitor is the energy stored in the capacitor. If you have to look for energy stored in the capacitor, it's also the work done. The same formula you will use. Hence, W equals to half QV equals half Q squared over C equals half CV squared. W is in joules, Q is in coulombs, V is in volts, and C is in farad. Let's see the example that we have on the board. A capacitor of capacitance is C. Capacitance is 5 microfarad. A capacitor of capacitance is 5 microfarad, C 5 microfarad, is subjected to a potential difference V, 1000 volts across the terminals. Calculate the energy stored in the capacitor. See that we have C and V. We are making use of half CV squared. Okay, now which is half times, what's our C? Please change this one to micro. 5 times 10 to the power minus 6. Don't use it as 5 like that, if not, you'll not get the answer. 1000 squared. Energy equals half times 5 times 10 to the power minus 6 times 1000 times 1000 over 1 over 1. 2 here 1, 2 here 500. Okay, energy equals 5 times 10 to the power minus 6 many 0 1 2 3 4 5 times 5 times 10 is power 5. Okay, 5 times 5, that's 25 times 10 is power minus 6 plus indices plus 5. Energy equals 25 times 10 is power minus 1. Minus 6 plus 5 is minus 1. Okay, which is the same thing as indices 25 times 1 over 10, which is 25 over 10. Energy equals 10 goes in 25, 2.5 joules. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.